Well, good morning, everyone. The paper that I'd like to present today is titled Defining Explanation and Explanatory Depth in AI, in Explainable AI. I know that Stefan already, let's say, presented his work a while ago, but considering we've been basically revisiting his work in ours, and now it's actually finally published, I thought it might be, let's say, cool and interesting for everyone, since, let's say, to different extents, sometimes maybe tangentially, but we're always like talking about this explainable AI, let's say, what it means, what it can use it for, and so on. So I thought it might be interesting to bring this back and discuss it. So let me just move our faces up the way. We now have like I would say like a fair amount of explainable AI approaches, and they sort of like tackle the problem, I would say, like from different angles at different levels. The problem is that we kind of don't have like a definition of what is an explanation is supposed to be, what it should I guess look at, and so on, which makes let's say, if we take different methods and a comparison between these rather cumbersome, fairly difficult. There's basically little guidance about what, as I said, like what an explanation should be, and so on. There are, I think, plenty of surveys and like other papers around out there in which they compare like different methods. They show that despite similar, if not identical input, you end up with basically different explanations for them, and sometimes even, say, they highlight some disagreement between these methods. They think models look at different parts of the input, and so on. And let's say overall, basically what we are missing is this sort of like requirements phase that maybe software engineers are really familiar with, of defining what are the, let's say, qualities, or what are the properties, the data that we may want to have for saying, okay, this is not just a statement, but it is actually an explanation. And in this sense, this paper, this work by Stefan, tries to bring forth and, let's say, argue what is called the manipulationist account present in the field of philosophy of science. Essentially, what this account argues is that explanations should be some form of generalization capable of answering what if things have been different kind of questions. This is, let's say, a bit tricky. There are a few moving parts in this, and let's say, the idea is that with let's say, some maybe machine learning specific constraint, this can be like transposed to explainable AI, essentially. To get you an idea of what the manipulationist account is, I'd like to ask you one question. Given these two explanations about essentially like a flagpole that has a certain length, its shadow has of course, like a certain length, then we have the sun that hits the flagpole at a certain angle. Which one of the two explanations do you think is better? There's no like right or wrong answer to this. It's like, let's say, there's a difference that might be interesting to be highlighted.
Maybe the second one.
Mm-hmm. Well, then that you are actually, if there's no one else that wants to chime in.
It's hard to say. I honestly don't know.
Okay. No, so basically, let's see, what this account argues is exactly what Gaul said, and this is that the second explanation, we might find it better because we actually have, let's say, if we look at the real world, the second explanation highlights better the causes of what is happening. Like we have a flagpole, there's a shadow, it's because of the sun. We are writing this sort of kind of causal relationship. While in the first case, it's true that you can essentially, basically it's like highlighting the inverse relationship in that case. Like you can, of course, like compute the other, I guess, quantities. Compute the length of the flagpole given the other quantities. But then sort of like you don't have this, I guess, connection to the real world. So that's what is kind of missing in this sense. And that's why the general opinion in this field is that explanations are all causal. This paper also takes and starts from actually Woodward's definition, which I reported here, very, let's say, simplified. And that is one that says that explanations consists of generalization that covers the actual case, and then a statement that actually is capable of covering these counterfactual cases, this, let's say, what if things have been different scenarios, if you will. If we then sort of like take this and transpose this to the field of explainable AI, you can think of explanations in this way of like saying, okay, we have a black box algorithm, we have a certain output that is given as a result of the of a certain input, and basically an explanation should be like a generalization that, let's say, okay, if we want to, let's say, put it in mathematical terms, these are more or less the formulations, but the idea is that you still like covering what is the actual output, and then for a possibly different input, effectively like its counterfactual outcome, you need to sort of have like both of these components to be, let's say, considered for a statement to be considered an explanation. Oops. The thing then basically this paper goes on and argues, let's say, some example of saying, okay, but do we really need both of these elements? Can we, let's say, make do with just with only one of them? Oops. Basically, this is taking one of the counterfactual, the definition of a counterfactual from one of the existing approaching. Is that they're saying, okay, we consider counterfactual when essentially we have a change in values in the input, and then we just obtain sort of like a different output. The thing is that in this case, for this kind of approaches, you need to, let's say, be sure that the counterfactual is actually valid. Like you're not, I guess, creating, if you think about it, like alternative realities in this case, which are not like valid or to the very least realistic for the data that you have. And at the same time, these kind of approaches is like maybe sufficient in some scenarios if they are able to like suggest this kind of generalization covering the actual case. On the other hand, if we only look at the approaches that may consider, let's say, the generalization part only, so focus mainly on the actual outcome of our algorithm, basically you can find the definitions like this one, which, if you think about it, they this kind of say formulations sort of like tells you what a model is doing, but there's no really, you're kind of missing out on the why part about this. And at the same time, let's say, we are still, of course, like missing this contrastive part. We don't know the, let's say, we're basically missing the counterfactual aspect. So we'll sort of like have an incomplete picture either way. So overall, let's say, starting from the philosophy of science field, we can actually we sort of like have a blueprint of what an explanation is considering. It should cover essentially like what is the actual and outcome of an AI model or a black box algorithm, and the counterfactual part. Now, basically, the rest of the paper then goes into defining and sort of like starts to presenting essentially guidelines for what we can basically what should be like a good explanation. How, let's say, how do these kind of explanations compare, pretending that we are dealing with, say, explanation that cover both these two aspects. And the author essentially proposes these two notions of abstractness of variables and generality of the explanation. For the first one, basically the idea is that we may consider like explanations that deal with more abstract variables, like the in this example, which basically like the second one, since it mentions this red stimulus. I mean, it's more abstract, if you will, than the first one, considering that red covers scarlet, but sort of like not the other way around. And in a sense, this kind of explanations allows us to cover more of those like why questions that we are interested in. Of course, you cannot, let's say, the idea is not to have like super abstract explanations, otherwise you essentially lose focus and may include like pieces of information that are not relevant to that specific scenario. So that's why the argument is sort of like to say, okay, we should prefer more abstract explanations that deal with more abstract variables, but at the same time, sort of like it's an act of balance with specificity, in the sense that explanations should contain basically the strictly necessary information that it needs to have. That's the gist of it, essentially. For the other dimensions, generality, you can think of it basically, the more abstract an explanation is, in a way, the more general. The only, let's say, caveat to this is that generality in this case, it's very, let's say, defined in a very specific sense, meaning that it should cover like more counterfactual cases, sort of like more inputs, if you will, and that is what like this concept of breadth of generality that is defined in this paper. At the same time, similar to abstractness, you want to sort of like balance out this breadth of the explanation with essentially its accuracy. It's like, okay, it's fine. We are, let's say, happy that an explanation covers multiple inputs, but of course, let's say, it should be correct for those inputs. Shouldn't be like, it's not a situation where the more the better kind of thing. It's always like a matter of balancing out. And this was very, let's say, condensed, this paper. Essentially, the whole, let's say, idea is explanations should be like contrastive. We should have this, what if things have been different, why something happened rather than another. And it's at the same time, if we aim to have like better explanations, we need to keep in mind these concepts of abstractness and generality, and balancing them with these ideas of specificity and accuracy. If you want to, like, say, dig into this kind of work, the paper is like a very, say, detailed examples arguing why each property is important and so on. This is, let's say, a very quick summary. of his work. And that's it for me.